Morning, guys, this is the continuity of the lesson 1 of mechanics. Here the practical applications of the mechanics in real life. The question says a car travels 9 kilometer in 15 minutes at constant speed, and we have to find its speed in meter per second. As you can see, s is given to be 9 kilometers, so the required search is should be in meter per second. So what to do, we have to convert the kilometer into meter, and 1 kilometer we have 1000 meters, so by multiplying this with 1000 we get 900,000 meter, the distance traveled by the car. And time taken is in minutes, 15 minutes. So 1 minute keeps 60 seconds, so it comes to be 540 seconds. As we are looking for the speed, and the formula for is a triangle formula, s is equal to vt, so we can say v is equal to distance divided by time. So here it goes, distance is 9000 and time is 540. And with the help of calculator, when we solve this, we can get oh sorry, one mistake here. You can see here 15 minutes, not 9. So write in 15, 59, it comes to 9000 as well. 900, it will be 900 meter. So here I will write only 900, right? Because it was 15 minutes, not 9 minutes. So 15 times 60, yeah. So it comes to be 10 meter per second. This is the answer of the question 1. I hope it is clear. Let's proceed to the next one here. Okay. It's stated that cyclists travel at 5 meter per second for 30 seconds, then turns back, traveling at speed 3 meter per second for 10 seconds. Find her displacement in the original direction of motion from the starting point or starting position. A simple case study, first we find the distance in the first part. It based on two parts. One in one direction, when it is moving with speed, v is what, 5 meter per second. It takes t is 30 second from say A to B, right? And then turn back. Here it turns, here you can see, here it turns and travels this in the original direction. And how long it takes, speed, now speed is taken as 3 meter per second and time is taken as 10 second, right? This is the case study. We have to find a total displacement. It means displacement here, displacement covered in one direction and displacement covered in other direction. Okay, we have to solve this by using the basic equation of motion. So let's start solving this. So we can say, we know that s is equal to vt, the first case from A to B, then B to, here we can say C to D. I can put the point CD. Okay, from A to B, speed is 5 and time taken was 30, so it covers 150 meter while traveling from point A to point B. Now for the return journey, after turning, towards the turning and moving towards the original direction from CD. Similarly, I can write SCD. That is again formula V times D. V times T is at, I will get V is here 3 and time is 10 second. As you can see, we are talking about displacement. So displacement is a directional quantity. So for the first case, A to B, it is moving towards the right, so we took it as positive. From C to D, it should be taken as negative, right? So I can put negative here, so it will be -3. So it comes to be -30 meter CD. So total displacement will be SAB plus SCD. So it was 150 plus and this was minus 30. So the final answer will be 120 meter. I hope it is clear to everyone. Okay guys, now another question. A parachutist falls from rest. It's given that it falls from rest. So initially it was in with velocity 0 meter per second to 49 meter per second. It means finally it will attain the velocity that is 49 meter per second over 5 seconds. So time taken was 5 seconds. Find her acceleration. So we need to find the acceleration here. It's a simple case, just applying the Newton's equation of motion, and v is equal to u plus at, or we know that acceleration is the rate of change in velocities. So if you can simplify this one to make a variable subjective formula, you can make from here the same formula you will get. So substitute the values. Simple is 49 minus 0 by 5. It comes to be 49 by 5. So with the help of calculator, we will get this will be 9.8 meter per second square. Don't forget to write the SI unit of the physical quantity what you are going to measure, right? And now take another question. Here it states a car travels down a slope of length 70 meter. Any this is coming down. Length is 70 meters. So we can write for the A part. I can write what is given distance of length mean distance, that is 70 meter. It is given a push and start moving at an initial velocity of 3 meter per second. It means u is given to be 3 meter per second and accelerate at a constant rate of this. So acceleration is constant, that is 2 meter per second square. Find the velocity at which the at the bottom of the slope. So we are looking for this v. So again, it's a case study for the constant acceleration. So by applying Newton's equation of motion, I'm applying here the third one. That is here I'm going to write 2as. It's coming down, right? This kind of figure, if you want. Figure is not as important as the concept are. So 2as is equal to v square minus u square. I can apply this Newton third equation of motion. So substitute values. 2 times a is 2, s is 70, sorry, v looking for, and 3 square use. So 4 7 20, a to 80, and this comes to here plus 9 will give you v square. So v square is 289. To square root on either side, we are looking for the velocity. So it can be positive or negative, plus minus, and because velocity is a vector quantity, so it can be positive or negative. But we know here the initial speed was 3 meter per second. That was, here I'm going to write initial speed was positive, so the final will be more than that. So I can say only v will be taken as plus 17 meter per second as a final answer for this problem. I hope you got it. Now the second part of the same question we are going to solve, that states find the time taken for the car to reach at the bottom of the slope. Okay, here we are looking for the time taken for the car to reach the bottom with the distance of the slope that's the same 70 meter, and acceleration was constant, that was 2 meter per second square. And what else? And yes, initially it was coming to from down with speed of 3 meters per second. Yeah. So here we can apply another equation of Newton's motion, that is S is equal to ut, because time is small, plus half at square. Okay, or you can apply another approach, the first one, v is equal to u plus at, because we you already have calculated with part A. Okay, so there are different routes to find the best answer. The right answer, 70 is equal to u is 3 and t we are looking for, plus half a is 2 square and t square. So for the simplification will give us t square plus 3t minus 70 equal to 0. So I can make the factor 10 t plus 10 and t minus 7. So here, 1 minute, yeah. Is I want to discuss with you the other route. Let's go with it. Any second method, you can say, the second yeah, method. If I can apply the first equation, that is v is equal to u plus at, right? B in the part A we have calculated, that was 17 and u was 3 and a was 2 and time we are looking for. So do the simplification. So 14 is equal to 2t. So t can give you 7 second, right? So both options you have. You can see there are multiple routes to solve the particular questions if you know the data given in the question. Okay, I hope you got the concept. Wish you good luck, and we will solve the further queries of questions in the upcoming video. Have a good time. Bye bye.